Today we're having a look at another question from the Edexcel Specimen paper. We're just going to look at part A today, which is differentiation. Part B we'll look at another day, which involves functions instead. So if you read through the question there, you see that we've got a function f of x equal to a mush of letters and numbers, and it tells us that it's a maximum point at P and a minimum point at Q, which we can see in the diagram anyway. And we want to show that tan of 2x is equal to root 2 at those 2 points P and Q. If you see maximums, if you see minimums, we're talking about stationary points. So the first thing you need to think of is differentiating and setting equal to 0. So let's differentiate then. How are we going to differentiate this? 4 sine 2x divided by e to the power of root 2x minus 1. It's quite a mess, but it's a fraction. It's a division of two functions. So we're going to be using the quotient rule. As if by magic, we have the formula here. The quotient rule is given in the formula book, so you don't need to memorize it. We've got f and we've got g. Unfortunately, this is also f, so you do need to be a bit careful about your notation. But f of x in the formula is what's on top, and g of x in the formula is what's in the denominator. So within a bit of abusive notation, I'm going to say f of x is 4 sine 2x, and I'm going to say that g of x is e to the root 2x minus 1. Now the rules to differentiate sine are sine differentiates to cos, what's inside doesn't change, but this sneaky 2 jumps out via the chain rule. Times is by the 4, 2 times 4 gives 8. The same is true for e. The derivative of e to the x is e to the x. So we're going to expect that the derivative of e to this weird thing is still e to this weird thing. But this unfortunate chain rule tells us we have to actually times by whatever the derivative is of this, which is root 2. So the derivative of this is root 2, and then exactly the same function. So, as I say, abusive notation using f and g's. This is actually f. This is the f from the formula. Let's now use the formula. So we're looking for the derivative, which is f dash of x, based on this one. And that's going to be using the formula. So this times by this. So those two minus these two. 4 sine 2x root 2 e root 2x minus 1. All divided by. And then that formula says g of x squared. So e root 2x minus 1 squared. We're looking for stationary points. That's when the derivative is equal to 0. So set this equal to 0. And in fact, what I'm going to do, I was going to write the denominator. I'm just going to times it by 0 and get rid of it straight away. What can we do next? Why don't we factor out e to the root 2x minus 1? Like this. Now we've got two things multiplied together equals 0. So either the first bracket is equal to 0 or the second thing is equal to 0. And I'm not sure if you know, but e to any power can never equal 0. That's because of the graph. There's an asymptote there. Never actually touches 0. It gets really close, but never actually gets there. So e to the root 2x minus 1 still not equal to 0. That means that this bracket must be equal to 0. And if this bracket is equal to 0, then the left-hand side is equal to the right-hand side. And if we divide both sides by 4, we get this. And if we divide both sides by cos of 2x, which I accidentally wrote again, we get this. And if we divide both sides by root 2, we get this. And guess what that means? Tan of 2x is equal to root 2, which is exactly what we wanted to show. Well, there we have it. That's part A done. Stay tuned for the next video where we'll look at part B, all to do with functions. Try these extra questions if you want a bit more practice.